Hi everyone, welcome back to the Internet Report, where we uncover what's working and what's breaking on the internet, and why. This week, we're looking at the top outage trends for ITOps teams to keep in mind for 2026 and beyond. We'll also review the global outage numbers, which showed an unusual trend over the holiday period. I'm Barry Collins, and I'll be hosting today with the amazing Mike Hicks, Principal Solutions Analyst at Cisco ThousandEyes. As always, we've included chapters in the episode description below, so you can skip ahead to the sections that are most interesting to you. And if you haven't already, we'd love you to take a moment to give us a follow over at Spotify, Apple Podcasts, or wherever you like to listen. So we've been covering outages on the Internet Report for years now, Mike. What made 2025's outages different from what we typically see?
If you think about a traditional outage, it's sort of a server crashes, network link fails, DNS breaks, we see some routing and anomaly taking place there, and sort of things clearly stop working. What we started seeing in 2025 was different things, where if I was looking at things in isolation, so individual components within a service provider themselves, they appeared to be sort of functioning correctly. All the health checks would pass, all the monitors show green, but then the actual service itself wasn't functioning. We couldn't actually get to it. So it's within the back-end service itself. I know that service is there, but it's not clear specifically which component failed. Now, so we saw this with AWS DynamoDB. The DNS servers sort of worked, the DynamoDB worked, but it was that interaction between them that was where that system appeared to sort of fail. And then we saw similar patterns with Azure and Cloudflare themselves, where individual systems appeared healthy, but it was that coordination between them that appeared to sort of break down. If you think about the scale of these systems and these environments and these vendors, it's actually likely there was some sort of automated process involved in actually sort of taking the actions. It was actually that coordination between them that's kind of lacked that full context. So as if your left hand didn't know what your right hand was doing, essentially. So where we had these systems, an automated process taking place, it was not doing it blindly per se, but it was actually doing it autonomously, making a decision to act sequentially on what it was actually trying to do that without full knowledge of the other processes that were taking place at the same time.
Let's talk about the AWS DynamoDB DNS incident. Walk us through what actually happened, because on the surface, everything was working correctly, right?
If we actually look at the system there, so the DynamoDB backend appeared sort of healthy. And what we say that the database responded normally, so it didn't appear to be any capacity issues themselves. The DNS infrastructure was functioning. So if it was actually querying specifically the DNS infrastructure, they were being answered and name servers responding. Now, the problem actually occurred with this interaction between the two systems themselves, where we're having sort of DNS entries overwritten. So what that meant was when the actual users are trying to connect, or the applications themselves were trying to connect to DynamoDB, we wouldn't get a DNS response. So it actually failed at that first point where we're making a connection. And because they weren't properly synchronized with the available DynamoDB endpoints, we didn't know where we were going to get to. So you may get a valid IP address, for example, but there was no name associated with there. So what happened then from a user perspective is there was failed connections and we actually couldn't get there. So something was actually broken. But if I was to look at those components individually, so if we take this to an enterprise perspective, in this case, the DynamoDB metrics will all appear green. If I'm only looking at DNS server and the DNS stuff itself, again, all going to appear green. It's only when I look at how these systems need to interact and work together that this coordination failure becomes apparent. This is why I actually need to look at this service holistically, not the individual components that come underneath there. How are they going to interact together and how they're working together is going to determine what the user experience ends up being.
You mentioned the Azure and Cloudflare instance had similar characteristics. What's the common thread across all three?
The unifying pattern was this coordination failure, the failure between sort of an otherwise healthy system. So we have an automated process which is making effectively an autonomous decision. As a task complete, it's acting on that. Now, the automation worked as designed, but what the design is likely didn't take into consideration is these edge cases. How would they interact in certain failure conditions? What if something occurred there that was interacting with that system, so we had some sort of timing slip? Now, the other sort of common thread across these was they weren't small localized issues. They actually cascaded globally within minutes. Because these systems are so interconnected, what might actually be a subtle timing issue where I slightly miss where I'm going to update a file or I'm going to overload that system. Because I have these vast interconnected systems themselves, it can actually propagate in seconds. And if we think about the systems involved, so we're thinking about the likes of AWS, Azure, Cloudflare, These are also then embedded in countless services. So it's not just those services themselves, it's the services that those providers supply to these other applications.
Companies are already using automation extensively: autoscalers, remediation tools, AIOps platforms. So what's changing that makes you think 2026 will see more of these interaction failures?
What's likely to change to that is the sort of the scope and sophistication is likely to shift. So if you think about what we're dealing with now, the automation is mostly reactive and single purpose. Scale when a CPU hits 80%, restart when you get a memory leak. If you think about the way we've got these interconnected systems and we're now sort of relying on these other third-party dependencies, we're utilizing these different areas with these best-of-breed solutions. We're dealing with all these different automation processes coming in place. And if we're actually utilizing a provider that's providing these services, other applications, we have my automated processes on top of their automated processes kind of interacting together. So it's these complex decisions that historically we effectively had human coordination for to sort of go between one to the other. It's that scale and that interconnection that's likely to change. How that's going to impact itself there is this speed, because we're dealing with these automated processes there. And as we've seen in some of these examples of the outage we saw to the back end of 2025 there, they can propagate these decisions across infrastructure in seconds. So where we'd have had this, do I actually press the button and wait for this system now, let me just see it's going, or effectively these sequential processes where I go through step at a time, now I'm effectively having them happening all at once. It's harder to roll it back, so I can actually see this propagate really quickly. And then the scope of it itself. So I'm coordinating this now across multiple domains, some of which I have no control or I don't own over. All I have responsibility for is that service delivery chain itself. And then again, because of this sort of third-party dependencies, each one of these systems or these domains can effectively be making a decision autonomously. I'll make a decision that suits my purposes without any consideration, if you will, to another process or different part of the service delivery chain that is not under my control. I'm going to optimize for my environment without necessarily understanding specifically what happens across the whole service delivery chain.
You've touched on 3 distinct risks: cascading failures, optimization conflicts, and intent uncertainty. Can you give us a concrete example of how one of these plays out in the real world?
So let's walk through a potential optimization conflict scenario. So you've got automated cost optimization, watching your cloud spend. Then you've got automated performance monitoring, sort of managing your database response times. And then you've got automated traffic routing to distribute load across different regions. So how could this then go wrong? So the cost automation sees expensive database instances in Singapore, right? And it starts migrating these workloads to cheaper, let's say US East instances themselves. Now, at the same time, the performance automation notices an increase for latency for the APAC users because we have these workloads starting to shift to different parts of the world. So the routing automation then sort of sends more traffic to Singapore, which increases the load, which triggers the performance automation to add more capacity. So remember, coming back to this cost automation, I actually see this new capacity, and I start migrating back to US East for these cost savings. What I'm starting to get is oscillation. Not one of those processes is actually wrong, but what they're doing is working against each other. So in this particular scenario, if I'm actually looking at it from the user point of view, what they're like to see is variable latency as the traffic sort of keeps shifting themselves. The infrastructure is then going to be in constant motion. It's never stabilizing. My costs stay high, so I'm not actually achieving anything from the optimization perspective because I'm paying for transactions. I'm probably paying for extra transactions and redundant capacity during this oscillation process itself. And because there's sort of no human oversight into this system where these automated processes are taking place, it can effectively go on for a period of time, before we actually start to look in to see what's happening itself there.
Cisco has shown how it improved visibility across its own infrastructure, and we'll share the link to that blog post in our show notes. But you said the challenge gets harder when you're dealing with systems you don't own. What do you mean by that?
If we think about how applications are developed or services developed, we're utilizing now multiple components of that. Some of it may be within your owned environment. And what I mean by that is effectively that it's under your domain of control, which means you have the capability to instrument it. But there's going to be a lot of those parts which are outside of your control. And this is what I'm saying about where the challenge comes in. So I have components within that I'm actually relying on that are effectively outside of my train of command there. So I can't instrument it. So I need to find another way to combine that holistic visibility together. So to be able to understand how that's interacting or impacting my users' experience themselves. So if I think about that, I have my internal instrumentation. I don't necessarily need to observe those services on the outside. But I do need to understand how they respond to my requests so I can actually see that holistic service delivery chain across there. And this involves every component of that. So understanding how it resolves the names. Is there any sort of third-party API that's actually called from there? With each of these systems, I may well have different automated processes. Because these are outside of my domain of command, I can't instrument those. I also have no understanding of what's going on. So therefore, what I need to be able to see is to look at that holistic service delivery so I can understand not necessarily how those automated processes are making those decisions, but how they're impacting my service delivery chain. So combining my instrumented environment, where I have these processes taking place there, understanding then when something comes in from the outside or something I'm relying on there, what the impact of that is, how those are all put together. And that's effectively that challenge, is being able to see that service delivery holistically, including those stuff that's within my domain of command and that stuff that isn't within my domain of command. And obviously the processes and the automation that's associated with each of those.
So what does that mean for organizations trying to get ahead of these interaction failures in 2026? What should they be thinking about now?
So if we think about the overall service delivery chain, we have components of that, as I say, that's within our domain of command and stuff we control and stuff we understand. This is obviously going to involve parts that we can automate and processes that take place within there. We have no control or understanding of these third-party processes themselves. So what we don't necessarily need to do is to try and build these systems to try and hope they coordinate. We're not just bolting on new processes on top. What we really want to understand is how the components operate within this service delivery chain. So if something happens to each one of these for an automated process itself, what we really want to understand is that fault domain itself. And by understanding that, we can also then start to build automation processes ourselves. So there may be components of that we understand every time we see this condition, this is what we need to do. When we start to see a slowdown coming from here, our mitigation plan within this is to spin up another EC2 instance. Don't worry about the services and the processes we can't control, but understanding how they interact with your service delivery chain with a view to optimization, but also mitigation should some issue occur. You will never be in a position to test and evaluate every possible edge case and scenario because of this domain of complexity, but also the scale and the fact there's a lot of this outside of your control and there's all sorts of different systems and things that can sort of take place. It's only when a unique combination that sort of interacts where you're actually going to be able to see that. But what we can do is by understanding where it is, we can understand and say which mitigation plan we actually want to put in place, and that can be automated itself, but also understanding the failover and the backup systems that need to be in place so we can maintain business continuity. If we lose this component, what is it that we can do to maintain business continuity? And this all comes from really understanding that service delivery chain. So effectively, what I'm saying is concentrate on the outcome, understand the fault domains themselves and the responsibility for each one of those and the function that they do, so that when something goes wrong or we have two interactions with those, you're in a position to be able to take steps around it.
Before we go, let's have a look at the recent outage trends. What have you seen in the December and early part of January figures?
So if we look at December, we actually showed elevated activity overall. Week over week, we did see declines during the actual holiday period. So from 364 global outages in early December, it dropped down to 199 after that holiday period. Now that drop during the holiday weeks is what we'd normally expect to see. But in the broader context, we saw December as a whole was significantly elevated compared to November. The activity began recovering in January, as we typically see. So the first full week of January saw outages increase by 28% globally and 90% in the US. By mid-January, continue that modest upward trend, and we're still tracking the month to see sort of where the January totals end. Now, with the elevated December numbers, we saw the expected holiday week suppression, but the month-over-month comparison sort of tells us a bit of a different story, what may have actually been happening operationally.
Just how different was December to what we normally see?
The numbers are striking. Global outages increased 178% from November to December. So they rose from 421 to 1,170. And the US saw an even bigger jump, 284%, which was an increase from 153 to 587. Now, if we actually look back historically, so I look back at 2022, 2023, and 2024, what we typically observe from that November to December is a lower outage activity, where they start to drop. This has then historically been followed by elevated activity in January, suggesting an accumulating maintenance work has been addressed post-holiday. Now, what we saw in December 2025 compared to previous years is we showed the opposite pattern. So we saw this elevated activity in December rather than sort of being deferred to January. So what this might suggest is that some network operators may have actually shifted their approach, potentially looking to complete maintenance-related work before the holiday period rather than after. And this could represent a more proactive operational strategy to avoid what we have seen historically, a concentration of activity in January, where we have operational tasks or maintenance tasks overlapping with each one. So then, potentially causing this cascading failures where we get these multiple tasks trying to complete simultaneously in this compressed post-holiday timeframe. So we can't definitively confirm that that's the underlying cause, but the observed pattern is notably different than previous years. So this December spike in outages had maintenance-like characteristics. The time of day we actually saw them, relevant to the impact zone themselves, and this typical holiday week suppression in late December. Now, the January numbers so far appear to be tracking low in December. If this is indeed a deliberate shift, it could represent different operational planning, spreading the work more evenly rather than trying to concentrate it into an all post-holiday period.
And that's our show. Please give us a follow and leave us a review on your favourite podcast platform. We really appreciate it. And not only does this help ensure you're in the know when a new episode is published, it also helps us to shape the show for you. You can follow us on LinkedIn or X @ThousandEyes, or send questions or feedback to internetreport@thousandeyes.com. Until next time, goodbye.